Greetings everyone. Today we are going to review our functions unit so far. So I'm going to go through some examples, write down what you feel you struggle with, okay? Take any notes necessary that will help you prepare for our next assessment. Let's go through this quick review. You guys have pretty much mastered this, but we are going to throw it on the final assessment. When we talk about the x-axis, so make sure you label your horizontal axis and your vertical axis correctly. Our origin is always in the center of the graph, so we want to label that as origin. We have our quadrant 1, 2, 3, and 4. So remember that we go, whoops, that's a little error there. Remember that we go counterclockwise from 1, all right? Ordered pair, we're going to graph some of those next, and the x-coordinate and y-coordinate are part of that ordered pair. So you just have to understand this concept, but we'll actually graph points. So let's graph a few here. Let's start off with A, which is 2, 4, which means from the origin, right 2, up 4 is my A value. My B value, left 1, then up 1. My C value, read it left to right. First, it's a positive 3. Positive is to the right. Second is up or down. Negative means down. So I have C right here. My G value is -2, -3. So that means left 2, down 3. There's my D. E value. We struggled with these ones a little bit on the first quiz. So remember, this means 0 left or right and down 5. So down 1, 2, 3, 4, 5. There's my E value. And F, remember this is right 5, 0 up or down. So 1, 2, 3, 4, 5. If you struggled with this in any way, my suggestion would be when you do this, draw little arrows, right? Positive is right, negative's left. Positive's right, negative's left. 0 doesn't matter, positive's right. And then I would go to the Y's. Positives up, negatives down, negatives down, negatives down, 0 doesn't matter. Okay, maybe that'll help you so you don't make a simple error. All right, is the relation a function? If no, we're going to state y. If yes, we're going to state the domain and range. Okay, so in this case, do I have any repeating x values? Do I use any x values more than once? And I don't. Okay, so is this a function? Yes. So we need to state the domain and the range. Remember 4 things: label DNR, use brackets, numerical order of the x values. Remember the first values are always for x, and no repeats. So if you have any repeats, do not include them in your list. Range, smallest value is 2, 3 is used twice, but I only want to write it once. 4 is used twice, but I only want to write it once. And close your set with a bracket. Now, as you're going through this, if you need to jot any of these down, I would suggest just pausing the video, jotting the example down. If you learn best by listening, then just keep listening through these examples and follow along in your notes. Make sure you've got these already somewhere in your notes. Take a look at this function. Is it a function? Excuse me, this relation. Is it a function? We want to make sure we have no repeating x values. We don't, so that's good. So yes, it is a function. We want to state the domain and the range. Again, dr brackets, numerical order, like on the number line, and no repeats. Smallest to biggest of the y values for my range, and no repeats. So this one's pretty straightforward. How about this one? I'm interested in the x values. Is it a function? If I look at these x values, uh-oh, I have 2 sets of repeats. So this would be a no because there's repeating inputs or repeating x values. Take a look at this list of coordinate values. -6, -7, -3, -1, 1. No repeats. That's good. Yes, it is a function. Let's state the domain and the range. D, R. 4 things. Label, bracket, smallest to biggest x values, no repeats, and smallest to biggest y values, no repeats. So check out that range. Okay, I start at -1, then I have 1 3 times, but I only write it once, followed by a 2. All right, let's evaluate the function. So in this case, we need to substitute in the correct number in for x. So first I want to identify that I have g. So I want to use g. It says g of -1, which means instead of x, I'm going to plug in -1. So I recommend writing the rule first, but instead of x, put parentheses, and in parentheses goes your value. If I calculate or solve that, 2 times -1 is -2. Bring down the +3. If I add -2 and 3, I have 1. So g of -1 is equal to 1. This next function says f, so I need to use f. Instead of x, it says -2. So I'm going to write the rule, but wherever there's an x, I'm putting a blank parenthesis, and wherever there's an x value, I'm plugging in a -2. Technically, there's a 1 out front, so if I distribute that 1, I have -2. Bring down the -1. -2 minus 1 is -3. So f of -2 equals -3. Let's try this one more time with different functions. On this one, I have the f function, and instead of x, I want to plug in 10. So I'm going to rewrite the rule, but wherever there's an x, I'm putting a parenthesis. Wherever there's a parenthesis, I'm plugging in a 10. Multiply first. Negative times positive is a negative. Half times 10 is 5. Bring down the +2. -5 plus 2 is -3. So f of 10 is equal to -3. G of 7. G function, 7, 7. I'm going to rewrite the rule, but wherever there's an x, I'm putting parenthesis. Wherever there's parenthesis, I'm putting a 7. If I distribute that negative, I just end up with a -7. 5 minus 7 is -2. So g of 7 equals -2. All right, let's analyze some data. Let's start off with analyzing this table. This table shows the number of meters a water skier travels after so many minutes. So remember, time is typically your x values. So let's talk about the amount of meters. The amount of meters blank after every minute. So what does it look like we're doing every single minute? So here it looks like I'm adding 600, adding 600, adding 600. So I would say increases steadily after every minute, or you could say by 600 meters every minute. I would be open to either of those options. Key thing though, it increased, and then how did it increase would also be important information. Next, I want you to make an assumption. How many meters will the skier have traveled after 6 minutes? So let's make a guess. If I increased by 600 every minute, what if I added 600 more? I would be at 3,600. So I can make a pretty good estimate and say 3,600 meters. Let's take some time to analyze these graphs. These graphs show the prices of 2 stocks during one day. So the timeline is 1 day. First, which stock appears to begin at a higher value? So at 0 time, stock A was here, and at 0 time, stock B was here. If their scales, assuming their scales are the same, we would say that stock B started at a higher value. Which stock appears to end at a higher value? So let's go to the end of the graph. Stock A is here, and stock B is here. So again, if the scales are the same, this dot is higher on the price. So I would say again, stock B. Describe the prices of stock A. Okay, so we want to describe how that graph changes. So if I take a look, first it increases, goes up in price, then it's steady, no change, then it decreases, it goes down, and then it stays steady again. So I want to describe that in words. Okay, so the stock initially increases, then remains steady, followed by a decrease, and ends the day, sorry about my writing there, at a steady price. Okay, so just make sure you describe every piece of that graph. Let's create a graph. So in this example, we want to draw lines or curves to describe the story given. So in this case, suppose you start to swing yourself on a playground swing. You move back and forth, swing higher in the air, then you slowly swing to stop. We want to sketch a graph that represents your height from the ground, changes over time. So my x-axis is time. Anytime time is part of the solution or the description, that's your x-axis, which means this is your height off the ground. So let's say when you sit down on a swing, are you above the ground? You are. So in this case, I start above the ground a little bit. As I push forward a little bit, my height increases. And then as I fall back down, I meet the ground, just above the ground. And then I swing backwards a little bit. So my height goes up a little bit. And then it comes back ground height. Then I swing forward higher. And then I come back to ground height. And as I go backwards, I'm even higher. And as I come forward, I'm just above the ground. And then I go forward. So now I want to start to slow down. So as I come back from the front, I'm probably going to drag my feet. So I reach the ground, I've dragged my feet. So when I'm back, I go a little less high. And then as I come forward and come towards the ground, I drag my feet again. So I'm a little less high. And then I come above the ground and I stop my feet. And I end. So I'm still at that same height that I started at because I'm not swinging, but I'm still sitting on the swing. So remember your graphs, they can have curves, okay? You have to consider the initial value. Where do we start? And you have to think about where do we end? Okay, do I end at the same value? Am I higher, lower? What happens at the end? All right, writing a story about a graph. We did this in class. So let's talk about what kind of story we could create. So a couple things to consider. We're starting at an initial value. We're above 0. We increase, so we have positive. Then we decrease a little bit. And then we increase a little bit until we're a little bit higher up. Okay? So I would say, you know what, I'm going to use over time. I'm going to say homework assignments. I started off with an initial homework assignment. Okay. Started by finishing, completing, handing in an initial homework assignment. I'm going to abbreviate. And I continued to hand in assignments until I had I'm going to generalize this, a big life event. Maybe that's a wedding. Maybe that is a big sports game. Maybe you're in a play, okay? Play at a big life event, whatever that is to you. And I didn't do homework for a bit. But then at the end, I turned in my homework again. Okay, so whatever story you can connect with, remember it doesn't have to be a physical height. In this case, I'm having a physical amount of papers. It can be anything that you can relate to. It doesn't have to be tangible either. It could be how you're feeling. We talk about feelings when we're dealing with graphs. We could talk about money. We could talk about your sports games. We could talk about video games. Okay. The topic of the story does not matter to me. What does matter is that we're describing the movements of the graph, that positive, negative, positive behavior. Matching. All right. Remember we did a big matching activity. So in this case, I want to identify key points on my graph and find which table has them. So this would be left or right 0, up 1. Whoops, that should be a 1. This would be right 2, up 0. This would be right 4, down 1. This would be left 2, up 2. Okay, so if you can, if it's a worksheet, label those values and then match. So let's see, which graph has 0, 1? Do I have 2, 0? Yep. Do I have negative 2? Yep. There is my matching graph. Let's try again. On this graph, I have a point of 0, 1 again. But now I have 3, right 3, 0, and I have left 3, up 2. So take a look, which table matches? In this case, all 3 points match that table. Graph the function. All right, let's take a look. In this case, my first step, isolate the y or f of x. Already done. Step 2 from our notes. So flip to your notes if you need to at this point. Use or choose 5 x values. I'm going to stick to the standard 5 values we've used in class. Step 3, plug in those x values and simplify. So my rule is a negative 2 with an x minus 3. Negative 2 with an x minus 3. Negative 2 with an x minus 3. I'm going to copy and paste that rule, and then I'm going to plug in each x value for x. Then let's calculate. Negative 2 times negative 2 is 4. 4 minus the 3 is 1. Negative 2 times negative 1 is 2. 2 minus 3 is negative 1. Negative 2 times 0 is 0. 0 minus 3 is negative 1. Negative 2 times 1. Negative 2 minus 3, negative 5. Negative 2 times 2 is negative 4. Negative 4 minus 3 is negative 7. Make sure you see a pattern. This is going down by 2 every time. That has meaning. So step 5 is to plot the points and create your graph. So at -2, 1, -2, up 1, -1, -1, left 1, down 1, 0, -3, 1, -5, 2, -7. So I can see that I have a nice, clean, decreasing line. Everything makes sense. Nothing's out of place. There is a pattern. That's what I'm looking for. All right, now not every function is going to have the y isolated. Sometimes I have to do the work. So in this case, I need to isolate y. So this is a tougher part of the unit. I really recommend pausing the video here and trying this on your own, and then checking to see if you get it right. So remember, when I'm isolating y, I want to use PEMDAS backwards. So let's start. Can I add or subtract anything to the other side? In this case, instead of subtracting 2x, I'm going to add 2x. Now, I can't actually add 2x here, so I'm just going to write it out. 12 plus 2x. Bring down your negative 2y. Next, is there anything I can multiply or divide? Yes, currently I'm saying times negative 2, so I'm going to divide by negative 2. That isolates my y. 12 divided by negative 2 is negative 6. 2 divided by negative 2 is negative 1. So I have a negative 6 and a negative 1x. Or you'll notice that I flip them around. I put the negative 1x first and then the negative 6. Either way works. Let's isolate y one more time with an equation that looks a little different. My goal is to isolate y. Currently there's a plus 1 in the way, so we're going to subtract 1 from both sides. If I do that, I have negative 3. I'm just going to write it all out, plus 1, and then a minus 1 on the end. This is messy. I want to leave it messy, so I need to get rid of these parentheses. If I distribute, I have a negative 3x. I have a negative 3. I'm going to bring down that minus 1. Hey, now I have like terms here. Bring down the negative 3x. Negative 3 minus 1 is negative 4. That looks nice and tidy and like all of the other equations that I've worked with so far. Let's put those two thoughts together. Let's go through our 5 steps we have in our notes. The first thing I need to do is step 1, isolate the y. So instead of a positive 4x, I'm going to minus 4x. Now, I can't actually minus 4x, so I'm just going to write it 3 minus 4x. But you guys, here's what's often forgotten. I didn't do anything with that negative sign yet, so I have to bring it down. Technically, there's a 1 in front of that y. So I need to divide everything by negative 1. This is the most commonly missed step. If I do that, I now have y equals negative 3 positive 4x. Okay, so what it does is it changes every sign in the equation. All right, second step, use or choose 5x values. Oops, I don't know why I put a 0 there. So do negative 1, then 0, then 1, then 2. I'm going to write my rule for my work. Negative 3 plus 4 parentheses. So wherever there's an x, I need a blank spot. So I'm going to repetitively write this down. Wherever there's an x, there's a blank spot, and wherever there's a blank spot, I'm going to put my x value. Now let's calculate. Remember PEMDAS. When we're simplifying, we multiply or divide first. So I'm going to take care of this multiplication, which says I'm going to carry the negative 3 over, but 4 times negative 2 is negative 8. Negative 3 minus 8 is negative 11. Okay, let's multiply first. 4 times -1 is -4. -3 minus 4, -7. 4 times 0, 0. That's easy, -3. 4 times 1 is 4. Positive 4 now. So -3 plus the 4 is 1. 4 times 2 is 8. -3 plus 8 is 5. Do I have a pattern? Let's check. This is adding on 4, adding on 4, adding. Hey, I have a pattern. We're adding 4 every time. That's good. I want that pattern. Now let's plot. -2, -11. We just off my graph a little bit. -1, -7. 2, 3, 4, 5, 6, 7. 0, -3. 1, 2, 3. 1, 1. That's nice and easy. 2, 5. 1, 2, 1, 2, 3, 4, 5. Okay, so as I take a look here, I got a nice clean line. I can't draw very good on here, so just pretend that that's nice and straight. Use your ruler if you need to. But I have a line. All right, so far that's what we've done up to this unit. So make sure you study, check out Google Classroom. Is there any assignments or worksheets we need to work on? Any review activities or worksheets that you need to finish up? And then let me know if you have any questions on any of these topics. But until next time, have a good one.